Let's take a look at this example. Please notice that this time we have given current, okay, but the current is expressed in form of the sinusoidal equation, okay. Also, please notice that we have given resistance and inductance. We have to find a voltage source. In order to find a voltage source, you're supposed to keep in mind that we are working with the parallel circuit. Let me remind you one more time that voltage source is equal voltage across the resistor and is also voltage across the inductor. Okay, so what we're supposed to do next? We're supposed to find the voltage across the resistor, okay, in order to find voltage source, because voltage across the resistor, one more time, is equal to the voltage source. So VR is equal VL and is also equal voltage source. This is equal IR times resistance, where IR is equal 2 amps and resistance is equal 35 ohms. Everything is equal 70 volts. Okay, so we found the voltage source. Next, we're supposed to find Z total. In order to find Z total, we are going to find first the inductive reactance. Okay, in order to do so, you're supposed to remember formula which says X of L is equal 2 pi FL. But we don't have given frequency. We have given omega. So this is also equal omega L. Okay, don't forget that we're supposed to always add J or angle 90 degrees. Now, omega is equal 1000. L is equal 200 millihenries. So X of L is equal 20 ohms, and don't forget that we're supposed to always add angle of 90 degrees. If you want to express this answer in rectangular form, you're supposed to write J 20 ohms. But we are going to deal most of the time with the polar form. So we have already resistance given, we have X of L, so I can use the product over the sum to find Z total. So Z total is equal resistance times X of L over resistance plus X of L, where R is equal 35 ohms times X of L, which is equal 20 ohms and angle of 90 degrees over, open parenthesis, 35 ohms plus 20 ohms and angle of 90 degrees. Plugging these values into the calculator, you're supposed to obtain the value of 17.36 ohms and angle of 60.25 degrees. Okay, so this is the value of my Z total. Next, I'm supposed to find Y total. Total admittance. Total admittance is reciprocal of the total impedance. So F1 over Z total. This is equal 1 divided by Z total 17.36 ohms and angle of 60.25 degrees. So this is equal 57.6 millisiemens and angle of negative 60.25 degrees. So this is my total admittance. Next, we have to find the conductance and inductive susceptance. In order to do so, I'm supposed to convert the polar form of my total admittance to rectangular. So if you are going to convert it, you are going to have Y total equals 28.58 millisiemens minus J 50.01 millisiemens. Okay, so this is my Y total, where the real part represents the conductance and the imaginary part represents the inductive susceptance. This is my G and this is my BL. Next, we're supposed to find I total. I'm going to solve I total using two ways, okay, in order to verify if our answers are correct. So before I'm going to find I total, I'm going to find IL. So I have IL is equal voltage across the inductor divided by X of L, where VL is equal 70 volts over X of L, which is equal 20 ohms and angle of 90 degrees. This is equal 3.5 amps and angle of negative 90 degrees. Next, I'm going to use Kirchhoff current law, which says that the sum of two currents, right, IR and IL, is supposed to give me I total. So I have KCL, which says I total is equal IR plus IL, where IR is 2 amps plus IL 3.5 amps and angle of negative 90 degrees. This is equal 4.03 amps and angle of negative 60.25 degrees. So this is one way to get the total current, but we always like to check if our answers are correct. Let's find the current total using Ohm's law. Let me write this over here. I total is also equal voltage source over Z total, where voltage source is equal 70 volts over Z total we found is 17.36 ohms and angle of 60.25 degrees. This is equal, so if I total is equal 4.03 amps and angle of negative 60.25 degrees. Next, we're supposed to compare these two values. As you can see, both of them are identical. If you will get the same values or very close to each other for I total, like we have in this case, it means that our calculations are fine so far. Now we are ready to find the true power. Okay, so P is equal 1/2 IR square times resistance. Why 1/2? Because we are talking about the peak value of my current. Okay, this is the sinusoidal equation, and this 2 represents the amplitude. Amplitude is nothing else, just the current peak. So that's why I have to use formula 1/2 IR squared times R. So this is equal 1/2 and I have 2 amps squared times the resistance, which is equal to 35 ohms. This is equal 70 watts. Okay, this is my true power. Next, I'm supposed to find the apparent power. So apparent power S is equal 1/2 I total squared times Z total. So if 1/2 I total is 4.03 amps raised to the second power times Z total, which is equal to 17.36 ohms, and this is equal 140.97 volt amp. Next, we're supposed to find the series equivalent circuit. So in order to do so, we're supposed to copy down the value of Z total. Z total is equal 17.36 ohms and angle of 60.25 degrees, and convert this to rectangular form. Okay, so you're supposed to obtain the value 8.61 ohms plus J 15.07 ohms, where the real part represents the resistance and the imaginary part represents the inductive reactance, X of L S. Okay, so I found the resistance and I found the impedance of the inductor. Next, I'm supposed to find the inductance. So in order to find Ls, I'm going to use the formula for the inductive reactance. So if X of L S is equal omega Ls, because I have given omega. In order to find Ls, I have to divide both sides of my formula by omega. Omega and omega will cancel out, and I will have Ls equals X of Ls over omega. So if X of Ls we found is equal 15.07 ohms divided by omega, which is equal 1000, of course, radians per second, and this is equal 15.07 millihenries. Next, we're supposed to draw the series equivalent circuit. So I have a voltage source, I have resistance Rs, which is equal 8.63 ohms, and I have inductor, which has inductance Ls 15.07 millihenries. And now we can say that the problem is solved.